Hi guys, I'm Plainwala. Welcome to Babaji's Flying Academy. So today we are doing ventilation. Ventilation is a easy chapter. It's nothing difficult. It's just what is ventilation? Ventilation is basically uh, the flow of air. Okay, so mostly I'm going to try and focus on the avionics ventilation because most questions come on that. Lavatory and battery ventilation is very small. Few points I'll just give you all, and that'll be good enough for the thing. The confusion most students will have is in ventilation, avionics ventilation, based on the types of configurations that are there. So on ground you have certain types of configurations, and in air you have certain types of configurations. So to ease it out, the way I was taught was you make this small table, okay, and the table's pretty simple. It's either hot or it's cold. Are you on ground or in air? Okay, so if you're on ground and it's hot, you go into open config, okay, and if you're on ground and it's cold, you will go into closed config. Okay, so there are majorly three types of configurations, which will be open for avionics ventilation, open config, then you have intermediate config, okay, and then finally you have closed. Okay, so if you see ground, you have either it's open config or you're in closed config. In air, on the other hand, you will have if it's too hot, you'll have intermediate config. Okay, because intermediate config, because if I keep it in open config, there will be a loss of pressure. So intermediate config, there is a small flap. There's an outlet, and in the outlet, what do you call, door for the outlet for the avionics ventilation. In that door there is a smaller door, and that smaller door is used to ventilate. So it's technically not open, and what do you call it's like it's in between the open and closed. We'll come to that later. And finally you have, if it's too cold, again you'll remain closed config. Okay, so now the idea is also key, the electronics is temperature sensitive, so too hot temperatures might adversely affect all of your electronics equipment, your wiring, and etc. Whereas too cold configuration again will hamper your electronics, and the moisture in there could cause different effects. Yeah, okay, so this is the major part of your ventilation. So let's get into the configurations now. It's easy way to remember is the small table, so try to remember it like that. Okay, and then we can break it down further. Okay, so avoid this top half, just let's focus on this bottom part. This is called open configuration. Okay, so what is the open circuit config? Okay, the open circuit config, you will notice that the skin air outlet valve. Okay, uh, first let's just talk about all the valves present and what it looks like. So you have an inlet valve, skin air inlet. The skin means the aircraft ka na, right at the so right at the aircraft ka boundary. Okay, that's called the skin. Just like we have skin, like that the aircraft skin, the skin air inlet and skin air outlet valves are there. Okay, you have a skin heat exchange in the center. Okay, which means let's take it again, your body as an example. Your body interacts with the atmosphere by transferring heat from the skin itself. So the skin heat exchange is basically around the fuselage, air is circulated, and because the air is usually this is employed when you want to cool down the system. Usually there is cold air outside, so what causes it to what do you call yeah what causes it to cool down is the outside air. Okay, so we have a skin heat exchange also valve, heat exchange like yeah, you have valves also of it. So if you see skin exchange isolation valve, skin exchange outlet bypass valve. Okay, so what are these? Skin exchange isolation valve is basically it isolates it. If it's closed, then this skin heat exchanger won't be working because there is no air flowing through it. Okay, one side you have blocked, and now because you have blocked this one side, the air cannot flow through it. Okay, because it's closed, right? So this, if this side is blocked, then this entire thing becomes useless. Okay, so that's the point of the exchange isolation valve. It isolates it. Okay, and then finally you have the outlet bypass valve. Okay, so the outlet bypass valve from the avionics bay. Okay, because the avionics bay is not just one area, there are a lot of different like what do you call rooms within it, you could imagine. Okay, another thing is the forward cargo or cargo heating I won't be doing. It's not important for it wasn't important for the Air India exam that I had given. You could read on it later, but anyways, skin exchange outlet bypass valve. Okay, so the skin exchange outlet bypass valve, if you see, this is the skin heat exchange, this is the outlet for it. Okay, so this basically, if you open it, it bypasses that outlet. Okay, so air won't be usually passing through here, it's just bypassing it and going through here. Okay, what else do we have? Okay, we have a blower fan. Okay, you could imagine it as this normal fan, okay, which just keeps on blowing air, and you have an extractor fan which sucks the air out of the avionics equipment and throws it towards the skin air outlet valve, otherwise your skin exchange isolation valve for your skin heat exchange. Otherwise it goes towards your cargo underflow. So again, if you notice the inlet bypass, skin exchange inlet bypass valve, and again this if you open this, okay, air is actually bypassing the heat exchange, is just going directly into the cargo. So there is still air. We'll come to those cases later also, so you don't need to worry. So now let's discuss about the oh yeah, wait, we are still not yet done. We have something called the air conditioning inlet valve. You do not take this into regard until you come into an emergency situation, an abnormal situation. Okay, so in open config, intermediate configuration, closed configuration, you will not be thinking about the air conditioning inlet valve. You'll only think about them in abnormal situations. One favorite thing I like to point out is Airbus, being the geniuses that they are, because very smart, they have mentioned throttle out here. I'd like to point out, I figured out where the throttle is written in this book. Okay, it's very surprising that people have not read these things. Okay, anyways, throttle is it's not supposed to be used usually. We call it thrust. I don't know if there is somehow there is a relation with throttle out here, or they're just like just written it to piss me off. I don't know. Please correct me if I'm wrong, but I don't think so throttle should be written out here. Okay, I could be wrong. Okay, so just don't pile on to me in the comments or anything. Okay, anyways, yeah, so let's forget about this part. Okay, and let's focus on the open configuration right now. Okay, so the open configuration is very straightforward. Okay, there is nothing involved in it. There's a skin air inlet valve. Okay, there's a blower fan, so it takes air from outside, it blows it, it goes towards the avionics compartment. Okay, the avionics compartment gets that breeze of air. Okay, it goes towards your from there it goes towards the extract fan. Okay, the cockpit panel ventilation, all your cockpit displays are LCDs. Okay, so those displays naturally heat up. If you touch your TV when it's on, or any monitor when it's on, you'll notice that there is a little heat generated, and it's usually generated. So what they do is they've kept a little gap so that air can flow through it, and it cools the systems also. So those display systems say air is also coming, it comes to the extract fan. There is after this, before the extract fan, there is a small point through which smoke detection is done. Later on in the chapter you will see this. Okay, and it goes to the extract fan. Extract fan takes all this air and it pushes it out through the skin air outlet valve. Okay, so now the major issues that people have is what's the point of the extract fan and the blower fan. Usually the blower fan is enough to provide ventilation. Extract fan is like 2 to 3 times the size. The extract fan is much bigger than the blower fan. So the extract fan on its own can cause ventilation to happen. Okay, otherwise it's usually kept off. Okay, it usually doesn't run, but in emergency conditions you can press the extract fan and pump a larger volume of air through the systems. Okay, so this is your open config. If you've noticed, it's very simple. Okay, now the open config has a very easy way to remember it. Okay, so your skin air inlet valve and outlet valve will be open. Okay, rest all your valves are closed. Okay, we do not remember, I'm not going to be considering this air conditioning inlet valve until we reach a abnormal situation. Okay, the open circuit configuration operates. Okay, it operates when the temperature is equal to or above 40 degrees Celsius. That means when it gets too hot. Okay, it's equal to or above 40 degrees Celsius. Okay, we're done with this. Okay, let's get here. Okay, so this is a closed circuit. Okay, now let's see the closed circuit configuration. It's again straightforward. Okay, we'll talk about the intermediate later because it's a mix between both these. So the closed circuit configuration, now think of it when you're cold, you want to cover yourself with a blanket, right? You want to keep the body heat with you, right? So again, we want to conserve this heat which this avionics equipment is making to maintain that temperature. Okay, so that's the point of the closed config. It's trying to close everything. It's trying to just use a skin heat exchange valve. Okay, and maintain the heat within the system. Okay, it does interact with the atmosphere through the skin heat exchange valve and that skin heat exchange. Okay, but yeah, it's also, it prevents the loss of pressure and prevents a loss of pressure. And you, like when you're in the when you're at 30,000 feet, the outside air is cool enough to help you dissipate all this excess heat. Okay, so it's cool enough for you to dissipate all this excess heat and not keep on getting a loss of pressure because you're throwing air out of the aircraft. Okay, because if you see in the open config, we had kept the skin air outlet valve fully open. Okay, and your skin air inlet valve was also fully open. Okay, so this point comes later on, it'll help you understand. Okay, so now we come straightforward out here again. It says throttles and all, let's forget that. Okay, these conditions are, we can do it later. Okay, so skin air inlet or outlet valve. Okay, your skin air inlet or outlet valve are both closed. Rest all valves are open. Okay, now the ground operations now will only occur, okay, when temperatures are below 40 degrees Celsius. Okay, so on ground, okay, on ground it will operate when the temperature is below 40 degrees Celsius. So if you remember that small table I had made, on ground there were two possible configurations. Either it's going to be fully open or it's going to be fully closed. There's no intermediate. Okay, so if it's too cold, the on-ground configuration is going to take if it's cold, it's going to take closed config. Okay, now let's check in flight. In flight had that intermediate and closed. Okay, this is where people get confused. Okay, so I don't think so there's much problem in the configuration. It's pretty simple. Avionics air is just keeping on being recirculated throughout the aircraft. Okay, and this here you can notice that there is a bypass. So this air bypasses the skin heat exchange. It gets pushed through and it comes to the blower fan. Blower fan pulls. These are all avionics other compartments also. Air is going through that. And then again you can see out here air is bypassing the skin heat exchange. So again it's called a skin exchange inlet bypass valve. Okay, and again you see air also, some air goes out here, it goes to the skin heat exchange, again it transfers air. Okay, it transfers heat, and that's how it keeps on circulating. Okay, so that's a closed config. Now people get confused between the transfer between closed config and intermediate config. So we'll come to that in some time. Just let me talk about intermediate, and then I'll explain how you understand the switching between the closed config and intermediate config. It's designed in such a way that the aircraft is not dependent on only one exact temperature, like how on ground you had 40 degrees Celsius. Like that, in air you have like a little bit of a range. So it decides, okay, when to switch between the intermediate and the closed config. Okay, so no, not now. Okay, this is a intermediate. Okay, so if you see the skin, one second, this is smoke. Okay, okay, so in the intermediate config, this outlet valve, okay, this skin air outlet valve is basically, it looks like this. Okay, it's this, and it's hinged along this, let's say. Okay, so it opens like this. Okay, and there is a small flap inside it, a small door. Okay, this door opens. Okay, this entire big thing does not open in this case. In open config, the whole big thing opens also, but in intermediate, the small door will open instead of the big door. Okay, now again think the aircraft is getting a little too hot, so it realizes, okay, might as well lose a little pressure. Yeah, but let's get rid of the hot air and we'll take fresh new air into the system, which is usually air which is circulating within the entire cabin of the aircraft. That air only is being used again. Okay, so you don't need to worry about where that comes. It's not yet coming in. Air condition inlet valve is still not open. Okay, air conditioning inlet, again I'm telling you, it will be only for abnormal conditions. Okay, so if you notice, it is not fully, if you see this configuration carefully, it is not fully closed, it's not fully open. If it was fully open, then we would need these to be open, both the skin air inlet and the outlet valve to be open. But the skin air inlet valve is not open. Okay, skin air outlet valve also, it is just that small flap is open. Okay, whereas the rest of the configuration makes it look like as if you are in closed config. Okay, so if you can imagine it, you can say ki your intermediate configuration has a closed config, but your skin air outlet valve is partially open, you could say, because that small flap is open. Okay, that's it. That's the point of skin air, of how your intermediate configuration works. So now the idea in this intermediate configuration is that the aircraft gets a little too hot. Okay, it will prefer removing some air, as I said, but now we do not want to have a pressurization loss, so we open only that small flap and get a little air out of it, and cockpit, like your air is coming through the cabin and the cockpit inside again and cooling the avionics system again. Okay, so this is what your system looks like. Okay, uh, you I I think so, yeah. Again, it says throttles out here. Airbus. Fabulous. Okay, so we are done with intermediate, we are done with close. Now the part comes, how does in flight the transfer occur between the intermediate and the close configuration? Okay, yeah. Okay, so you need to understand this by thinking of it on two different scales. Okay, uh, if you all understand this, you all can, like, take a screenshot of it. Okay, but now try to think of it on two different scales. So what do I mean by two different scales? If it gets too hot means 35 degrees, okay, and temperature increasing. Okay, now how does it distinguish flight operations and ground operations? Is thrust for takeoff has been set. That's how it knows कि you're going in flight. Okay, that's a whole different point. Okay, the closed circuit configuration operates when the skin temperature is beneath the in-flight threshold. Beneath the in-flight threshold. So that means it is 32 degrees Celsius temperature decreasing. That's what it looks for. Okay, so okay, yeah. Anyways, sorry. So beneath the in-flight threshold means 32 degrees Celsius and temperature decreasing. That's when you will think of close config. Until then, forget about this 35 degrees and temperature increasing. Okay, so that's when the switch occurs. The switch between your intermediate and closed config. So the aircraft does not want to keep on switching between, it does not want to keep on operating that small flap. Okay, because what's the difference between the intermediate configuration and your closed configuration? It's that small flap that is keeping on opening and closing, which is in your that skin air outlet valve. Okay, that small flap. So it doesn't want to keep on operating that flap, close, open, close, open, close, open, close. Okay, so what it does is it keeps in its mind, okay, if the temperature is 35 degrees Celsius and increasing, I will open that flap. Okay, so 35 degrees Celsius and increasing, it opens that flap, it goes into intermediate configuration. Now, when it comes back down, when the temperature comes back down, let's say, temperature is coming back down. Okay, temperature is coming back down, temperature reaches 35 degrees Celsius. Okay, it will still not close that flap. It will say, okay, you have cooled down. We will still maintain that flap open because we want it cooler. Okay, so it will say, okay, keep on cooling down and reach 32 degrees Celsius and keep on cooling down after that also. Then he will say, okay, you have reached 32 degrees Celsius and temperature is decreasing, might as well close that small skin air outlet flap. Okay, so that's how this is supposed to be decoded. People get confused on how this gets decoded. Okay, 35 degrees Celsius and temperature increasing. Again, now once you have reached closed configuration, it's the same concept. It converted, it became closed config. Okay, now once he's become closed config, he's not again going to open the flap immediately when he reaches 32 degrees Celsius. What is going to happen is, it's going to say, okay, let the temperature increase. Let it increase. Let's see if it's increasing. Temperature keeps on increasing. It says, okay, let it increase. It reaches 35 degrees Celsius. It says, okay, is the temperature increasing after 35 also? It says, okay, 35 degrees Celsius, temperature increasing, open that small skin air outlet flap. Okay, so that's how the system determines between your in-flight between your intermediate and closed configuration. Okay, so we are done with this. Now we come to our favorite parts, which is your abnormals. Okay, I need a diagram. Okay, so let's do the blower fault or extractor fault. Okay, the blower fault will occur. This blower fault light will come in when there are four conditions that are met. Either your smoke is detected, otherwise you have blowing duct pressure is too low, otherwise you have computer power supply has failed, and finally if your duct overheats. That's the case for blower. For extract, you have only three conditions. Uh, Extract fan pressure is a little too low. Computer power supply is again failed. Otherwise, smoke is detected. Okay, these are the two reasons why what do you call the fault lights come on. Whereas, if you notice, it is in a closed circuit configuration, and because this is an abnormal situation, air is added through the air conditioning valve, uh, air conditioning inlet valve. Okay, air gets added in, and if one of them is not working, it tries to maintain that closed circuit config. Okay, and keeps on circulating the air. Okay, um, that's the case for in case you have a blower fault or you have an extractor fault. If you have both a blower and extractor fault, then you come into something called a smoke config. Okay, when smoke is detected in the aircraft. Okay, so smoke config is here. Okay, now smoke config is again straightforward. It keeps it in, it does not want to circulate the air continuously. So what it does is it allows air to go through. Okay, because again, you for smoke configuration, both your push buttons must be set to override, your blower and your extractor. Okay, both will be pushed to override. That means your blower fan has stopped, your extractor fan is running. As I said, there is a smoke detector after your cockpit ventilation. Okay, and fresh air is added through your air conditioning inlet valve. Skin air outlet valve is partially opened to ventilate the smoke overboard. Okay, skin heat exchanger is not used to prevent recirculation of what you call the smoke. So it does not want the smoke to come again back into the system, and it does not want to even if you notice, the avionics bay and the cargo underfloor side is also isolated. Okay, now there is also something called a AEVC failure. Okay, what does AEVC failure mean? Okay, it is basically your controller has failure. Okay, so if this controller has failed, which handles your ventilation, okay, that has failed, then it is the same as your smoke config. It's just that you have this in your emergency elect panel. You have a push button for your what do you call engine one smoke push button. Okay, so that engine one smoke push button, if you press it, it allows only the fuel pump number 1 in each wing tank to run. If I'm not mistaken, it's the fuel pump number 1 in each wing tank. Yes, to run. So that's the only way you will realize whether there is a smoke in your what do you call avionics, or you have a what do you call you have a AEVC failure. Okay, otherwise the fault lights on the blower and extractor fan both will come. But in case you have smoke also out there, then your gen 1 line smoke that on your emmer elect panel, you'll have that to press. Okay, so again you will be pressing both the push buttons. Again, the blower fan will stop, extractor fan will go on, skin air outlet valve will allow little air to go overboard, but it makes sure that okay, you have like slight fuel penalty because you're using air conditioning air continuously, but you have your avionics equipment cooled. Okay. Now if you notice, there is no fire extinguisher or anything in the avionics equipment. That's because in case there is a fire in there and you use the fire extinguisher, then it might affect the other computers in that system. So the best case in out here is you try to reduce the electrical load, and you try to what else, you try to reduce the electrical load, and you try to ventilate the smoke out as much as you can. Okay. uh, Again, extractor fan will keep on running, skin air inlet and exchange isolation valve, and the skin exchange outlet valve, again both are all are closed. Okay. In abnormal operations, you have to remember, abnormal operations always your air conditioning inlet valve will be open. In all abnormal operations, you will notice also that your extract fan will always run. Okay. Okay, battery ventilation. Battery ventilation is again straightforward. There is a small venturi kept within the aircraft which allows air to go overboard. Okay, so battery ventilation is not kept on these controllers and all, because batteries are very important in case there is any failure or anything. The batteries are your last electrical supply for those 20 minutes. So they have kept a venturi, so it's always, it's like a foolproof system. It'll always be throwing little air overboard, but that batteries are ventilated for sure. Okay. Batteries is kept near the forward cargo. Okay, and has a separate ventilation that is meant to be fail safe, fail operational technology. That's why they've kept a venturi. Okay, so the venturi allows little air to always be discharged overboard. Okay. Lavatory and galley ventilation, on the other hand, the same place through which your outflow valve is. Okay, your outflow valve for your air conditioning, that outflow valve, say only you are taking extraction fan draws ambient air through the cabin and the lavatories and galleys and exhausts it near the outflow valve. Okay, so it takes it all and keeps it near the outflow valve. There's a diagram for it. I don't have that with me right now. I didn't save it, sorry. But you can see the diagram. It's very simple. If you all have an FCOM, you can see the diagram. It's just that it's the same place where your outflow valve is. Right next to that, they discharge all the excess air. So it helps in, again, will help you in pressurization also later. There is a small extract fan near that outflow valve, which actually is not related to this avionics wala extract fan. Avionics ventilation extract fan, it's its own separate extract fan, but it goes to the same outflow valve of our air conditioning chapter. Okay, and if the inlet valve is not fully closed in flight, then no action is required, since there is a non-return valve which prevents air from going back out. Okay. If the extract valve is affected, then you have an issue, because then you'll put your blower and this thing to override. Okay, and you might lose weather radar image on both NBs. Okay. If you notice on this side, it is written that there is a small internal flap opening. That's what I was trying to talk about. Okay. Yeah, on ground, if your aircraft is parked, okay, and there is a lot of heavy rain, then what you do is you just push the extract push button to override. And again, that's straightforward, because if I push the extract push button to override, it will, what do you call, it will push the aircraft into a closed config, so it will prevent like water entering from the inlet valve or anything. Okay. Yeah, that's it. We are done with ventilation. Okay, thanks. Please like, share, subscribe, and try not to go for classes. Yeah. Okay, best of luck, guys.